Hello everyone, I am Hằng. In this video, I will talk about the rotation in motion of rigid bodies. So, from here, cross product to moment of inertia, I did it in the previous videos already. So in this video, I just talk about the kinetic energy of rotation, and I will give you the summary of this all this part. So I immediately move to the kinetic energy of rotation is right here. Here, suppose that you consider a rigid body, like the door. When you open the door or close the door, so you perform a rotation. Next, we know that on the door we have many particles, and when we combine them together, so we have the rigid body is the door. Now I consider just one point on that door, so I say that particle I. So the kinetic energy for the particle I is defined by this formula. Now if I want to consider the door, so I have to sum all the particles on the door like this. Next, take a look here. If here I write a linear velocity, so remember we have the relation between linear velocity and angular velocity like this. V equal R times 2 omega. So here, if V here, so I don't write V, I write R times 2 omega and square them, because here I have a V square, so here I have to square them. Next, 1/2 is a constant. I move it out from this sum. And omega is the angular velocity of each particle on the door. Actually, each particle on the door has the same angular velocity. Why? Because the angular velocity is defined based on the angle with respect to time. When you open the door, for example, you have a 45 degree. So all the particles on the door have the same angle at the same time. Therefore, they have the same angular velocity as well as angular acceleration. But in this case, we just talk about the angular velocity only. So if all particles have the same angular velocity, so I get the angular velocity out from this sum like this. And remember, this sum we denote like I, and we call this one is a moment of inertia. So this sum is I, so we call this one is a moment of inertia. So we rewrite it like this. So we have this formula, and we call this one is kinetic energy of rotation. Now I have to remind a bit about the I here. The I here is a moment of inertia. It depends on the shape of the object. If the object have this kind of shape, I mean a solid cylinder, and the angle, the rotational axis through the center of mass like this. So I divide by this, the same for the others. If if you want to consider the rotation with respect to the, not to this axis, but with respect to this axis, so the formula of I you divide by this way, for where m is mass of the object, d is the distance from the old rotational axis to the new rotational axis. Okay, so now we move to the summary. Okay, here is the summary. So you should remember the summaries, because when I show the video, so you have to waste maybe hours to listen to the videos. But when I show the summary, so you just need some minutes, but you include the everything in the lecture to one slide. For example, here I give you the summary for the rotation. So here is the relation between the angular position delta theta and the distance s, like this. When you have a angular position, you can calculate the angular velocity. Here actually we have a instantaneous here and average here. When you have a distance, you can calculate the linear velocity. Here instantaneous. You also can calculate the average, but this one I showed in the other videos. I don't want to show it here because we have a relation between them, so I remind a bit here only. And here is the relation between the linear velocity and angular velocity, like this. The magnitude and the direction here. When you have angular velocity, you can define the angular acceleration. Here is the instantaneous, and here is average. And when you have a velocity, you can define the tangential acceleration. And here is the relation between the linear tangential acceleration and angular acceleration, like this. Here I talk about the tangential. So remember, we also have a normal acceleration. It's like this. So this one is formula for normal acceleration. If you want to convert to the omega, so you write by this way, because you have the relation between the linear velocity and the angular velocity, like this. So here you write r omega and you square them, and then the next you neglect r with the denominator, and you have this formula about the direction. So you know, you write vector r, but actually vector r from the center and point out, and the normal acceleration from out point to the center. So therefore you have a minus here. Next, remember, I remind you about the linear motion, the straight motion. So you have some equations like this. And now if you talk about the angular motion, rotation, so you have the same equations like this. So here is like this. Remember this formula, you usually use it when you solve the exercise. So try to remember them, okay? Try to remember them. Next, what do you have? Next, we have the torque, and what else? The torque and the second law of Newton, and like that. So if I want to talk about them, so I have to move based on the acceleration and the the linear acceleration and angular acceleration, but I don't have a place to write here, so I move this one down. The velocity and acceleration, angular velocity and angular acceleration down. To describe the next one is the force and the torque. Next, so this one I move from here down. Next, when you have a velocity, you can calculate the kinetic energy, okay? And when you have the angular velocity, you can calculate the kinetic energy of rotation. Okay, this formula, where I is a moment of inertia. You should remember it based on the shape of the object. If the object doesn't have any shape that you know, so usually they from given you can find, they will give you the number of I. And if they give you the shape of the object, for example, cylinder, sphere, or a rod, so you remember the formula for I, okay? Next, when you have acceleration, you can calculate the force based on the second law of Newton. This one is very important because later you apply it to consider the motion of an object. Straight motion, okay? Next, when you have angular acceleration, you can calculate the torque by this formula. remember I here, I remind you here, so I don't need to remind it here anymore. And alpha here is the angular acceleration. Now you have the relation between the, look, you can create the force based on the acceleration, linear acceleration. You can create the torque based on the angular acceleration. Here you have a relation between the linear and angular acceleration. That means here you have a relation between the force and the torque. It's like this, like this. But whenever you have I, so please remember this formula also, okay? Because sometimes you don't consider the rotational axis which pass through the center of mass. So you have to focus on this formula to calculate the I. Okay, so this summary is important, I think. So at least you have to remember this summary for this part of the motion of rigid bodies. Thank you for listening, okay? And try to remember the one I put in the frame. In general, try to remember all of them, especially the yellow one, because based on the yellow one, you can solve many exercises. Thank you for listening.